Hi, I'm Gilbert Chen from Sunrise Metal. Today, I will answer the 10 most common questions about the vacuum die casting. If you are an engineer, a designer, or just curious about advanced die casting techniques, this will help you understand the key points. Vacuum die casting is an upgrade of high-pressure die casting. The special part is that before casting, the air inside the mold is removed. This way, when the melted metal fills the mold, there's no air getting in the way. What's the benefit? The casting becomes denser with fewer air pockets, higher strength, and a smooth surface. That's why industries like automotive, medical devices, and aerospace prefer vacuum die casting. Compared to normal die casting, vacuum die casting makes parts much better by reducing air bubbles. Removing air from the mold helps hot metal flow in more smoothly. This lowers defects like air pockets, serrage, and cold shots, making the parts stronger and durability. Also, the vacuum keeps out oxygen and dirt, so the part has more stable quality and fewer defects. Of course, vacuum die casting can't get rid of all air bubbles, but for cars, medical devices, and electronics that need strong and reliable parts, it works really well. Yes, it can, since vacuum casted parts have a smoother surface, a denser inside, and more stable size accuracy. Less polishing and CNC machining are needed. Also, vacuum die casting makes parts that are closer to the final shape, so many complex designs can be cast directly. This helps lower machining work and cost. Vacuum die cast parts are more stable for welding because they have fewer air pockets, which reduces welding bubbles, cracks, and weak spots. It also reduces oxide layers, allowing the metal to bond more evenly, making the weld strong. Additionally, vacuum die castings make aluminum parts more flexible and durable, which makes them great for applications like car bodies, battery casings, and medical device frames, where good welding quality is really important. Compared to regular die casting, vacuum die casting can handle more complex designs better. After the air is removed, the melted metal flows more easily into deep spaces, thin walls, and detailed structures. This makes vacuum die casting great for thin-walled parts, deep cavity parts, and lightweight designs. However, if the design is too extreme, it may still need to adjust the mold channels, gates, and vacuum controls to make sure the parts come out with good quality. Usually, the wall thickness for vacuum die casting is between 1.5 mm to 4 mm. In some areas, it can be as thin as 1 mm, but this depends on the alloy flows, the mold design, and how stable the vacuum system is. If the walls are too thin, the metal might not fill the mold completely. If they are too thick, it could cause serrage problems. So, the wall thickness needs to balance the strength, cooling speed, and how easy it is to make. Yes, vacuum die casting works better with aluminum alloys that flow easily, like ABC12, A380, aluminum silicon 12. These alloys fill complex molds more easily in a vacuum and have fewer defects. However, materials with a higher melting point and poor flow, like steel, are not suitable for vacuum die casting. The final material choice depends on the part's strength needs, the manufacturing process, and costs. Vacuum die cast molds usually last longer than regular ones. This is because the vacuum environment reduces the contact between metal and air, lower the risks of oxidation and wear. Also, since the metal flows more smoothly, it causes less high-speed impact and heat stress on the mold, which helps reduce wear and cracking. However, the actual lifespan of mold still depends on material choice, cooling system, and regular maintenance. Proper mold management is also important. The cost per part is higher, but it's more cost-effective overall. It is because vacuum die casting requires more expensive equipment, more complex mold design, and strict process control. So the initial investment is higher than regular die casting. However, in the long run, it can reduce scrap rates, lower machining needs, and improve part consistency and lifespan, which helps lower overall production costs for high-precision, complex parts or those requiring high reliability. Vacuum die casting offers better value for money. Vacuum die-cast parts offer more stable and smoother surface finishing with fewer air pockets during processes like anodizing, electroplating, and coating. Issues like bubbling, peeling, and chipping are reduced, making the coating stick better and improving corrosion resistance. The surface is cleaner, the process smoother, and the final result looks better. However, final surface quality still depends on mold precision, casting process, and post-treatment. For high-demand industries like medical and automotive, vacuum die casting offers better, more reliable surface finishes. That's it for today's top 10 vacuum die casting questions. I hope this helps you understand vacuum die casting better. If you have any more questions, feel free to leave a comment. Don't forget to like and follow for more updates on die casting technology. See you next time.